In this lecture, we'll introduce you to the concept of generators in Python, a powerful feature that enables handling of sequences in a memory-efficient and elegant manner. Generators are a type of iterable, like lists or tuples, but they don't store their values in memory. Instead, they generate values on the fly. The beauty of generators lies in their ability to yield multiple results sequentially, each time pausing and resuming their state. This is achieved using the yield keyword, as you'll see shortly in the hands-on sessions, which temporarily halts the execution of the generator function, returning a value to the calling function or calling party. Upon the next request for a value, the generator function resumes right where it left off. Consider a scenario, for instance, where you're tasked with processing a large log file. Instead of reading the entire file into memory, a generator can read and yield one line at a time, thus efficiently utilizing memory and allowing for the processing of very large files. In bioinformatics, analyzing long DNA sequences can be memory intensive. Generators can sequentially process segments of these sequences, identifying patterns or mutations without the need for loading the entire genome into memory, for instance. When analyzing financial data like stock prices, you might want to process real-time data or large historical datasets. Using generators, you can handle this stream of data, detecting anomalies or trends as new data is generated or read. The creation of a generator is quite similar to defining a normal function, with the key difference being the use of the yield keyword instead of the return keyword or return statement. Let's explore this through an example, possibly the most heavily overused Fibonacci sequence generator example of all time. In this example, each call to next on the generator object would return the next Fibonacci number. The yield keyword is what differentiates a generator from a typical function. When a function encounters a yield statement, it sends the yielded value back to the caller and pauses its state. Upon the next call, it then resumes right after the yield statement. Similar to list comprehensions, Python also supports generator expressions, a more concise way to create generators. For example, in this line of code that we have here, we're creating a generator that reads lines from a file, yielding them one by one. And unlike list comprehensions, they don't hold the entire result in memory. We can summarize the benefits of generators in four main categories. Firstly, efficiency. Generators are memory efficient, as they yield one item at a time instead of holding an entire sequence in memory. The next being lazy evaluation. They compute values on the fly, which is useful for large datasets or streams of data. Generators maintain their state between yields, making them suitable for iterative processes where the current state needs to be preserved. And finally, simplicity. They can simplify code that would otherwise require complex loops and data handling structures. Hopefully by now you've developed an appreciation of why generators are a fundamental concept in Python and how they offer a streamlined approach to handling sequences and iterative data processing. Let's now head over to the hands-on coding session to see these in action.